Imagine a poison so tasteless and odorless that for centuries it was called inheritance powder, a substance that shaped royal courts, Victorian medicine, and modern agriculture. This is arsenic. It is a metalloid, meaning it has properties of both metals and nonmetals. It exists in several forms, but inorganic arsenic compounds, particularly arsenic trioxide, are the most toxic. The World Health Organization classifies inorganic arsenic as a Group 1 carcinogen, meaning there is direct evidence it causes cancer in humans. Like cyanide, arsenic isn't purely man-made. It occurs naturally in soil, groundwater, and volcanic rock. In countries like Bangladesh and parts of India, naturally occurring arsenic has leached into drinking water wells, affecting over 140 million people, one of the largest mass poisonings in history, according to the WHO. There's no dramatic villain here, just geology. Arsenic disrupts cellular energy production by interfering with enzymes involved in the Krebs cycle, the same metabolic engine that cyanide attacks, though through a different mechanism. It essentially starves cells of usable energy. Chronic low-dose exposure causes peripheral nerve damage, skin lesions, and over time, cancers of the bladder, lung, and skin. Historically, arsenic trioxide was the poison of choice for European aristocracy from the Renaissance through the 19th century. It was nearly undetectable until 1836, when British chemist James Marsh developed what became known as the Marsh test, the first reliable forensic chemical test for arsenic. It was a turning point for toxicology and criminal prosecution. But here's what surprises most people. Arsenic has also been medicine. Arsenic trioxide is still an FDA-approved treatment for a form of leukemia called acute promyelocytic leukemia. In clinical trials, it achieved remission rates above 90% in newly diagnosed patients. The same compound that poisoned kings is saving lives in oncology wards today. And it shaped culture in stranger ways. In Victorian England, arsenic-laced green dye, known as Shields green, colored wallpapers, fabrics, and candles. When damp, mold could metabolize the arsenic into a volatile gas. Some historians have proposed this contributed to unexplained illnesses in poorly ventilated homes, though the theory remains debated among scholars. Today, arsenic remains a genuine public health concern. Not through wallpaper, but through groundwater and food. Rice, which absorbs water efficiently from soil, tends to accumulate more inorganic arsenic than other grains. The U.S. Food and Drug Administration has set action levels for arsenic in infant rice cereal, specifically because infants consume it in concentrated amounts. This doesn't mean rice is dangerous. It means dosage, as always, is everything. Arsenic stays in the body longer because it is processed more slowly. The liver tries to break it down into forms that can be removed through urine, but some of these byproducts are still harmful. In cases of severe poisoning, doctors use chelating agents, special medicines that bind to arsenic and help the body flush it out. But for long-term low-level exposure, there is no simple cure. That's why prevention, safe drinking water, and regular monitoring are the most important protections. Arsenic shows how the line between poison and medicine often depends on the amount and how it is used. It has been linked to famous poisoning cases, contaminated groundwater, and traces in parts of the food chain, yet it is also used in hospitals to treat certain cancers. The story of arsenic is not just about danger. It is also about how chemistry shapes everyday life in ways people often do not notice, through water, soil, food, and even medicine.